Hello and welcome to the channel Understanding.Concepts.Of.Physics. Hope you all are doing well, and today we are going to start another topic named rotational motion. You can just make notes in case if you want to make your personal notes while you just see the video. And the topics which we are going to discuss in this particular video is seen in on the screen. Introduction is going to discuss with rigid body, what rigid body is, the axis of rotation, the torque, the couple, and the inertia. So in this particular video we are going to just revise the basic concepts which we are going to utilize in the coming series of the videos. So from today onwards we'll be having daily video posted on topics going forward for rotational motion. So let's just quickly start on to what rigid body is. So a rigid body is something whose geometric shape and size remains unchanged under the action of an external force. So if there is suppose a body, and if you apply a force on that body, and if the body does not changes its shape or size, then such body is called as the rigid body. So a stone can be a rigid body, maybe a fan which is rotating over your head is also a rigid body because it does not change its shape or size when it is rotating. So a rigid body is the one whose geometric shape and size remains unchanged under the action of an external force. Okay, so this is the first definition we have seen. Now the next is something called as axis of rotation. Now suppose if I have this rigid body, and if I drill a small hole through this body and I pass a rod into it through this body, and if I push it from this end, this body is now going to revolve around that point, around this line. Now this line will be called as an axis of rotation. Now what happens is, okay, when the body is rotating, this body is made up of very different small particles. Now when the body is rotating like this, the particles will be in circular motion, something like this. They will be in circular motion. Now this would be the radius of that circle, this would be this radius of the another circle's radius, and another circle's radius. So each particle will have their own radiuses. Now all these circles ka center lies on a straight line, this straight line, and this straight line will be called as an axis of rotation. So that's what we have here. When a rigid body is rotating, all the particles of the body are in circular motion. So when the body rotates, the particles are in circular motion. That's the key property which differentiates rotational motion with circular motion. In circular motion, you have a particle which is going around the circumference of a circle. But in a rotational motion, the entire body, like in case of a fan, like this represents a fan. Now when the fan is rotating somewhat like this, the entire fan is in rotational motion. However, the particles of the fan are in circular motion. Okay, so when a rigid body is rotating, all the particles of the body are in circular motion, but the centers of such circles lie on a straight line, and that straight line is called as an axis of rotation. So a very simple definition. You can just pause the video and copy this definition in order to learn it later on. Next is something called as torque, a very important property in physics which we are going to study now. Now torque is sometimes also called as moment of force, and it is denoted by a Greek character written somewhat like this, and this Greek letter is called as tau, T-A-U. Now torque, or the moment of force, is basically the turning ability of a force. Okay, so turning ability of a force means when you apply a force on any particular object, and if that object turns, the turning ability of your force will give you the torque. Like in case of a door, let's say if this is the door and this is the latch of the door, this is the handle. So let's say if the door opens this way, swings like this, then when you apply force on this handle, the door actually rotates like this. Now if the handle was not put over here, or it was put at the center, or it was put at the corners, you would see that if you apply force at this point, the force would be infinite. the force would be very large in order to open the door. If it was at the center, the force would have been still larger, and everywhere, every door you might have seen that the handle is always away from the hinges. So the more the radius, lesser the force would be. Okay, so that's what torque is. Torque is the turning ability of a force, is called as torque. Okay, so torque is also called as moment of force. This we have already discussed just now. Torque is also called as moment of force. The turning ability of a force is called as a torque. And let's say, suppose I have this rigid body of any irregular shape, and there is this point where I am applying force in this particular direction, and the radius is, let's say, this is r. Okay, this is r. Now when I push the body, then the radius vector is this way, force vector is this way, the body is going to rotate like this, then the torque is given by r cross f. Now we are not going into details of how this formula comes and all. We are into an intermediate stage of what we are going to study in rotational motion. So torque is given by r cross f. All of these are vectors, and as you know that a cross b is equal to ab sin theta. A cross b is ab sin theta. So r cross f would be rf sin theta. And if theta is equal to 90 degree, then sin 90 will go out to be as 1. So you just have r into f. So if you want to maximize torque, you either maximize r, you either maximize f, or you make the theta as 90 degree. That's why the door gets opened very easily if you apply force. If you apply force at the cornermost point as well as perpendicular to the door. Okay, so that would be the best case to open a door. Then anti-clockwise torque is always taken as positive, and clockwise torque is always taken as negative. So something rotating anti-clockwise is positive torque, and clockwise torque will be taken as negative in order to solve numericals. Then torque is, since it's a vector quantity, then it's given by the right hand rule. So you can just assume wherever you are sitting, if there is a door, just curl your right hand in the motion of the door's rotation. So let's say, suppose if this is the door, and if the door is rotating like this on this side, then you apply the right hand rule, and you will get the thumb pointing upwards will give you the direction of the torque. Just try to align your thumb in the direction of the rotation, align your fingers in the direction of the rotation of the door, and the thumb will point out, your right hand thumb will point out where the torque is. Okay, torque produces rotational as well as translational motion. Like suppose if you might have played a game of pen fight, where let's say this is the pen, and if you hit the pen from this end, then you will find out that the pen actually rotates as well as it goes forward. That means it is also moving in linear motion as well as it is also moving in rotational motion. That's why torque creates rotational as well as translational motion. Then comes unit of torque. Torque is given by Newton meter, as the formula itself suggests. It's the product of r and f. So r is radius, that is meter. Force is torque. Force is not Newton. So you have a force torque unit as Newton meter. And the dimension is L2 m1 t minus 2, and this is because you have torque is equal to r into f. R is L1 and force is L1 m1 t minus 2. So this will give me L2 m1 t minus 2, the dimensions for torque. So this is what it is. So what torque is. So I have discussed 3 definitions over here. I hope you have enjoyed the video, and we'll be discussing about couple and inertia as well in the coming videos. Thank you so much for watching. Watch the complete video. Keep on following the videos. Now things will be posted on daily basis, and let's see let's see if you are able to make notes of that. Thank you so much for watching. Subscribe the channel in case you have not done so yet, and keep watching. Thank you so much.